Hello, in this video we'll be learning about parallel lines and transversals. In the previous video we just learned about angle relationships when we had transversals. In this one we'll be looking specifically at parallel lines that are cut by a transversal. So for our first slide here we have line A is parallel to line B. So the theorem is if two lines are parallel then corresponding angles are congruent. So this is true when the lines are parallel. So we know that angle 1 and angle 5 are corresponding. So I can say angle 1 is congruent to angle 5 when the lines are parallel. 2 and 6 were also corresponding. 4 and 8 were corresponding. And finally, 3 and 7 were corresponding. So from this theorem, I can gather all this information about these angles. Our next theorem states if two lines are parallel, then alternate interior angles are congruent. So from here, we can gather that 4 and 6 are alternate interior angles, so because of the parallel lines, they will be congruent. We also know angle 3 and angle 5 are alternate interior angles, so because the lines are parallel, those are congruent as well. And if any time, of course, you need to pause the video, write these notes down, please do so. Our third theorem states if two lines are parallel, so A and B, then alternate exterior angles are congruent. So angle 1 and angle 7 are alternate exterior, so angle 1 is congruent to angle 7. We also know that angle 2 and angle 8 are alternate exterior angles, so they are congruent as well. Our fourth theorem is if two lines are parallel, then same side interior angles are supplementary. So this is different than the other ones because we're no longer talking congruent. We're talking supplementary. So angle 4 and angle 5 are on the same side of the transversal on the interior, so they're same side interior. So angle 4 plus angle 5 equals 180. We also know angle 3 plus angle 6 will equal 180 as well, because they're same side interior angles. And as you probably guessed, our fifth one will be about same side exterior angles. If two lines are parallel, then same side exterior angles are supplementary. So 1 and 8 are same side exterior angles. So if I add those up, those will equal to 180. And we also know angle 2 and angle 7 are same side exterior angles. So those will be supplementary as well. So let's do some practice with it. If the measure of angle 1 equals 60 degrees, let's see if we can find all the rest of the angles. So go ahead and pause the video, try it out yourself, and we'll come back and see what we can do with it. Okay, let's give it a try. So if we start with angle 1 being 60 degrees, we can go on further and we can give the other angles. So angle 2, okay, sorry about that break. Had a quick interruption there, but let's get back to it. So we got angle 1 being 60 degrees. We know that from corresponding angles that not only will angle 1 be 60, but angle 5 will also be 60 degrees. From vertical angles, we know angle 3 will be 60 degrees. You could have also said alternate interior angles 3 and 5. And we also know that from linear pair, 1 and 2 will be 180 combined. So we subtract 60 and get 120. Vertical angle here. Alternate interior angle over to angle 6. Vertical angle to angle 8. Vertical angle to angle 7. So that fills in the rest of my angles there. Okay, here we have a little more going on if you notice. We have two sets of parallel lines. Line A and line B are parallel. Line C and line D are parallel, each cut by transversals. So pause it for a second and try it out. All right, let's come back to it. Angle 1 is 52 degrees. Vertical angle to angle 3, 52. Alternate interior angle to 5, 52. Vertical to 7, 52. 1 and 2 form a linear pair, so 128. Angle 4 will also be 128. Linear pair, 128, 128. So we started this side pretty well. Now let's jump over to this side. These two lines cut by this transversal. If angle 1 is 52, the corresponding angle to angle 1 is angle 9, which will also be 52. Or you could have said same side interior angles equal 180, which makes this 128, 128, and 52. When we jump down here, alternate interior angles 52, 128, 128, and 52. And this worked, of course, because both sets of lines were parallel. Let's look at one more example. Here we have the measure of angle 1 equals 3x plus 6. We have measure of angle 5 equals 2x plus 12. Now you have to ask yourself, how are these two angles related to each other? Well, we know that they're corresponding angles, and we know that corresponding angles are congruent. So I can say 3x plus 6 equals 2x plus 12. Of course, if I wanted a geometry setup, you could say measure of angle 1 equals measure of angle 5. So let's solve. Subtract 2x. So you get x plus 6 equals 12. Subtract 6. So x equals 6. So now it wants the measure of angle 2. But angle 5 might be easier because we already know something related. So 2 times 6 is 12 plus 12 equals 24. So angle 5 is actually 24 degrees, which will make this 24 as well. Angle 6 forms a linear pair with angle 5. So 180 minus 24 is 156. So angle 6 is 156 degrees. Of course, angle 2 and angle 6 are corresponding, so that makes that 156 as well. Okay, and this is very similar, so if you want to practice, go ahead and try this out. So pause the video and try it out. Okay, I'm going to quickly run through this one. Angle 3 and angle 6 are same side interior angles, so I can say measure of angle 3 plus the measure of angle 6 equals 180. So that means 3x plus 8 plus 2x plus 12 equals 180. 5x plus 20 equals 180. Subtract 20. 5x equals 160. And finally divide by 5. So x equals 20. Let's see there. 5 goes 120 times. 30. So 32. Now if I plug back in for angle 3, it's going to be 32 times 3, which is 96 plus 8, which is 104. Obviously, this is not drawn to scale. Angle 2 will be 76. Angle 4 will be 76. 1 will be 104. 104, 76, 76, and 104. And then you can fill in the blanks from there. And that's it for how we work with parallel lines. There is one more quick concept, I'm sorry, that when we went back to those statements, we'll just do that in another video. So thank you for watching the video, and hopefully you got something out of it.